Hi everybody, I'm Jake and this is 2DS from DS. I'm coming to you today from, well, this would be Winchester, Idaho. I'm just passing through, going up north, going and visiting some customers up in northern Idaho and spend some time with a coworker. And figured it would be worth my time to talk a little bit about some of the stuff I saw a little over a week ago at Atmosphere 2018. From Aruba Networks. And one of the things I saw that made me really interested was NetInsight, aka the RASA acquisition that Aruba made here a little over a year ago. And the reason I want to talk about NetInsight is because it's about something that I'm very interested in, which is machine learning. And I think quickly, machine learning, everyone's like, there's a lot of terms: big data, machine learning, big data analytics, AI, and machine learning in this case is really talking about building a data model and teaching a computer to understand that data model. And so I saw an example on the internet I thought was really interesting. It was about dogs. I'm a dog guy. I've got 2 dogs at home, and their example was they taught a computer to recognize pictures of dogs. Now I think the interesting part that it was this particular example. They taught a computer, and that there was only, like, out of all the images they used, there was only like a handful of dogs, and most of them were wolves or coyotes or whatever, and they basically said, this is not a dog, this is not a dog, this is not a dog, and they said, here's a couple pictures of dogs, and it was able to very accurately identify pictures of dogs because they had built a model of what a dog is and what a dog isn't. And that model is what it uses, and there's a bunch of attributes. How big is the dog? Is there scale? Is there proportions? You know, those types of things are what it's using to identify a dog. And I think that's really interesting as it comes to Wi-Fi, because there's all these things that we can identify based on these models. Now, the tricky part about these models is that somebody has to teach a computer these models. And so last week and a half ago at Atmosphere, we got to talk with the people from the NetInsight team about some of the work they're doing. And I can't talk about all of it, but I will say that they have some pretty sophisticated tools that deal with machine learning and building of these models that can then be distributed elsewhere. They were talking about examples where they were out, with a backpack full of devices, collecting data to train the model on how to identify certain things. And I think that's really interesting. I haven't seen a ton of NetInsight in production. And I think a lot of these machine learning, big data analytics products, I think one of the challenges is most of them are in the cloud, which means there's Amazon, Google, and Microsoft all want their tax for running this in their cloud, and so it costs a lot of money to just do it, right? So I think to an extent, I think that our exposure to some of these tools is limited by some of the costs of spinning some of this stuff up. But that said, I thought it was really interesting the data they went out and had some guy walk around and survey, well, I don't know, survey, but have devices acting and collecting this data, and they used it to develop these attributes of Wi-Fi, signal to noise, signal strength, all retry rates, upstream, all kinds of pieces of data that they were then collecting and using that to train a model of what something looked like. And then being able to take that model, actualize that as data, classify that data, and then correlate it to other data to do something cool. I think that's an interesting use case. From my perspective, I think, the example they gave us, that I can't talk about, I think had limited applicability directly, but I think the same process that they were talking about was interesting and very applicable. but I think it's early. I think they've built a platform to do this. I'm not sure how many of these models exist in the actual product you go buy today. But I think that they are building a sophisticated platform to do this. And I think that, to me, is the interesting part. The models will come over time. And I thought one of the interesting things they said was, we built this model and trained this model, but if you were to take it to another type of business or, like an airport or hotel or whatever, that you'd probably have to retrain the model because this model was very specific to this particular customer. Which is, kind of cool. And also kind of sucky in a sense that the model was so specific that it doesn't have a lot of carryover. So I think the part that for me was, it's going to take some time. We're going to have to figure out how these models work. We're going to have to figure out how to correlate these into actionable pieces of intel. That's going to take time. That said, I think that the activity of doing that is really good, because eventually we'll get there to where we can identify very sophisticated things based on a bunch of just seemingly random data, which, like I said, it was really cool. And I don't want you guys to get to the idea that I don't think NetInsight is a good product, or it's early. I think we're very early in the machine learning parts of wireless networking, and I think RASA was on the cutting edge, and I still think that the NetInsight product is on the cutting edge. And eventually it will get there. The reason I say that is that during the keynote they had somebody from Ohio State University, which is a NetInsight customer, and they were like, yes, we had this problem in this one room, and it had been there for years and multiple iterations of the network. Brought in NetInsight, and NetInsight told us how to fix it. And I was like, that's super cool. And then they told us the why. And it's like, well, really, all we had to do was do some channel planning and power, just some channels and power, and everything's hunky-dory. And I was like, so what you really mean is any wireless engineer worth their salt who went on site and looked at this probably could have fixed it themselves. Now, granted, this is a contrived example that they wanted to talk about in the keynote. I get it. And I know the guy. I know one of the guys over at OSU. He was a Aruba Insider with me a couple years ago at Atmosphere. Super nice, very intelligent guy. So I in no way think that, they didn't do it. But I think that the point is that while the example was kind of crappy because a wireless engineer could have just solved that problem, I think the interesting part is that NetInsight could solve that problem on a much larger scale than I could. Because I would have to fly in, go to the site, look at it, maybe collect some stuff remotely and determine we had some issues. And then come up with a plan, put a fix in place, where NetInsight just said, hey, we think if you do these things, it will fix it. I think that that's a great example that, yes, any wireless engineer worth their salt probably could have walked out there, looked at it, done a survey, looked at these things, or looked at the data off the controller and figured it out. But NetInsight was able to take and build a model of what it saw and correlate that to a specific issue and give them advice on how to fix it, which I think these are things that they were able to do all of this with just like telemetry basically from the APs. So I long term, I think that the better we get at writing these models, and I think there's a model selection process that we may come up with like 10 models for this thing that they were working on, which I thought was cool. I just don't know that the specific iteration of it. I thought it presented exceptionally well, but I think that instead of saying, oh, we're gonna have to come up with a different model in a different place, it may be one of those where we need to do some model detection. Can we accurately detect those things? Can we sanity check the model? without having to just go custom build the model and custom collect all the data each time? Or can I build like 10 models or 20 models and have the system say, you know, if I run the algorithm like this, I think this is the most accurate model we could use, rather than having to go out and collect all of that data manually and train the model custom to you. Maybe you still have to get the best results or in really complex environments to get things. But I think long-term model selection, automated model selection, will help with some of that. And once we have enough models, I think we can probably, you know, the time it takes for us to get to the point where we're deriving value from these machine learning frameworks is going to be a lot less. One question that always comes up with AI and machine learning and all of these things is this going to take my job? I'm 37 years old. I may have to come to some hard realizations that within my life it could take my job, or a significant portion of my job. But I will tell you this: those are the parts of my job I love. Is a machine ever going to learn how to design Wi-Fi? Yes. I think I will see that in my life, in my lifetime before I retire. I think I'm an advocate for programmability and those types of things, and I think that I would encourage people to wireless engineers. While today it's super important that we understand RF and how RF works, I think long term, I'm a big advocate for Python programming and programmability and networking, but I also think data science is another place where there's a big opportunity for us to grow our skill set. And I think that, I'm not saying everyone needs to go out, but I think you should understand some basic concepts of machine learning and big data and AI and what's the other one? Forgot it, but whatever. I mean, neural networking, that was the one I was thinking of. I think those are really important things to have a good understanding of, not a mastery of, but you should be able to walk into a conversation and know the difference between machine learning and neural networking. And I think some of those things are going to be bigger to us in the long term. Maybe not in the next 5 years. I think we've got, I would say we probably have a good 8 to 9 years before, risk of, a machine taking my job as a wireless engineer is relevant. But I think we do have to come to the terms that, it may change. Instead of surveying, we may be doing on-site model building. We may be looking at data and analyzing data to correlate the correct model. Or we may be looking at, specific issues and teaching the machine how to identify and learn those. So, not all doom and gloom, but I do think that there is going to be a large component of this, simply because I don't think that we have the data or the ability to correlate complex metrics to be able to maximize wireless performance. I don't think we do. And so I think machines are going to do some of this better than we did. But that's not to say that we are going to be replaced. We'll probably just be doing other things, right? Which I'm okay with. So I think I've rambled on enough for today. I'm going to let you guys go, and hope everyone has a great day, and see you back here on 2DS from DS.